Hello again, this is Dr. James Camp from Lee College in Baytown, Texas, and this is part 2 of my commentary on Chapter 2 of Big C++ by K. Horstmann. Here we're going to talk about input-output fundamentals in C++ and about the string data type. So sometimes when you're writing a program, you actually know what the values of the variables are going to be, and you can hard code those into the code. But most of the time, that's not how it works. Often you don't know what value is going to go with which variable when you're writing the program, but the user is going to know when the program is running. So this is a situation where you need to take input from the user. First, the user needs to be prompted. So we're going to have a cout statement that says something like, enter your first name, or enter your age, or enter the size of the circle that you want to calculate the area of, or something. Then we're going to read a value from the keyboard. And that's the topic of the next couple of slides, is how we use an input statement. To read values from the keyboard, we're going to input them from an object called cin, which stands for console input. Okay, the double greater than operator is sort of a read from send to command, so it's going to read from cin and send that value to a variable. Okay, and that variable has to already be defined. You can't just drop a new variable in on a cin line. And note that you do not use end line with an input statement. The user is going to hit the return key after they type in their input, and that's going to jump you down to a next line anyway. So you don't need to tell the computer to start a new line. In fact, you can't. End line is an output operator, not an input operator. One cool thing about the way C++ does input is that you can read more than one value in a single input statement. So you can, here's an example of a prompt, cout, enter the number of bottles and cans. Notice that they didn't put an end line after that statement either. Most of the time you want the person to enter the values on the same line as your prompt, so it visually looks to the user like they're going to type the numbers right after you ask for them. And if you want the user to put both values in on the same line, you can say cin greater greater bottles greater greater cans, and it will read both lines right away. Alternatively, if the user wants to press the enter key between them, they can do that too. They can type 2 enter 6, they can type 2 tab 6. You know, any kind of white space is going to be treated as just a separator between values. Okay, so that's what we're going to say about input at this point. What about output? Which do you think the user prefers to see on their gas bill? $1.22 or $1.21997? The answer is probably the first one, because that looks more like what we expect dollars and cents to look like. So how do you override, since C++ defaults to giving you 6 significant digits, how do you override that? The answer is that we use output manipulators. Output manipulators are found in the iomanip library. And so we're going to have to pound include iomanip in addition to pound including iostream. The manipulators, like fixed, which sets a fixed number of decimal points, and set precision, which tells it how many decimal points you want to use, are just passed to cout using the standard output operator notation, the less than sign. And you can in fact chain all of the things that you want to send to cout into one really long line of output if you want, like this example shows in the slide here. You can also separate it into, you can say cout fixed semicolon new line cout set precision to semicolon new line cout price per liter. You can separate them all into a bunch of cout statements. because until it sees an end line, cout is not going to break to a new line. There's also a set width manipulator, set W, that sets the width of the next output field. So the width is the total number of spaces, including the data that you're actually printing, but it allows you to pad your data and set them up as columns. So for example, if you wanted to print the population of every state, you could print TX and then have set width 10 to have enough room for all of the population of the state. Actually, 10 might not be enough. You might need set width 15 or something to pad that column with enough spaces that it would line up on the right-hand side. And then the next one you'd say CA for California, and you'd have the same set width 15, and it would line it up on the right-hand side. Here are some examples of output formatters. You can see out fixed and then set precision 2 and get 12.30 from 12.3. It'll actually, with the fixed manipulator, it will actually add zeros to your number to get the desired precision. Example of the set width 6, after the colon, it creates a 6-space column to print the number 12 in, so it prints 4 extra spaces and then the number 1, 2. And then at the bottom you see they did set width 6 before the colon. Well, that just prints the colon in a field of 6 spaces, and then the 12 gets printed normally. Okay, so let's look at some examples of how these work. If we have quantity, then set width 4, and then we print quantity, which has the value 10, we're going to have this quantity colon space space 1, 0. Price, then we have fixed, set width 8, then set precision 2, and then price. We're going to have price and then 3 spaces and then 19.95. If we say price fixed set precision 2 without the set width, then the 1995 just comes right after the price. What if we set precision 3? We'd get 19.950. What if we set precision 1? We'd round it to a single decimal point. Okay. If we had a number of prices per ounce, and we did a set precision 2 and then set width 8 for each column, we'd get the output at the bottom of the page here, 1024, 11, 11720, 699, and they all kind of line up there on the right. There is one major difference between set precision and set width. Once you set the precision, that is fixed for all of the double values that come after it until you set the precision again. Set width, on the other hand, affects only the next value. So you have to keep using set width over and over and over and over again for every value that you want to be padded with spaces. Okay. One quick tip, I'm not sure why they dropped it in here, but one quick tip from the book is that before you write C++, try doing the problem by hand. Pick simple values to test your algorithm, and it's a good idea to even write your algorithm out in comments in your code file and then go through one comment at a time and write the code after it. Okay. Last topic for this chapter is strings. Strings are actually sequences of characters, where each character is actually its own little variable of the char type, which in turn is just a series of bits in computer memory. The bit patterns are actually standardized. Okay. By default, C++ uses ASCII the American Standard Code for Information Interchange, which is a 1960s vintage character encoding, so it's not very advanced. In fact, each character is only 7 bits long, not even the full 8 bits that you get with a byte, specifying 128 codes, which is just enough to catch every character on an American English keyboard. Okay. 26 uppercase letters, 26 lowercase letters, 10 digits, 32 punctuation marks, and then 34 extra characters, what we call control characters. That includes the space and the new line character, but it also includes many for controlling old-fashioned consoles and printers like line feed and form feed, and there's even a terminal bell character that's supposed to make your terminal make a chiming sound. See, there it is. Character 7 is the bell. You can see here how ASCII is organized. If you organize it by hexadecimal, then the first 32 are all control characters. The next 32 are all punctuation marks and digits. Then you get the uppercase letters, and then the lowercase letters come after that in a kind of parallel sort of way. Okay, Unicode has begun to replace ASCII in most modern computing. Okay, it's actually a superset of ASCII. The first 128 codes in Unicode are the ASCII 128. But the extra bits, which can be up to 21 bits per character, allow you to get up to 2 times 10 to the 6, so like 2 million characters, which enables worldwide languages and even leaves room for emoji. So if you have a website that is Unicode aware, you can actually use emoji characters in your username or your password or something like that. Most of them prevent you from doing that, but there's no reason you couldn't in Unicode, except if whoever wrote the website decided not to let you. But I have a brother-in-law who likes playing around with web content and trying to use emoji in his screen names and things like that, just to see if those Unicode characters break their code or not. UTF-8 breaks Unicode characters into a series of 8-bit blocks, which allows some compatibility with older systems that expect 8-bit characters, such as C++. UTF-16 is a 16-bit version that's often used by the most modern websites, and some modern programming languages are UTF-16. Now, C++ strings can hold Unicode characters, but C++ code cannot. You have to specify the Unicode characters using escape sequences. One of the things I love about C#, the Microsoft successor to C++, is that it's fully Unicode aware, so I can use the Greek letter pi as one of my variable names if I want to, and there's nothing wrong with that. It compiles perfectly well. Okay, so strings are sequences of characters. You include the string header so you can create variables to hold strings. Most compilers these days will let you use a string type without including the string header, but it's a good idea to include it anyway, just to get all the functions that belong to the string class. String variables are objects. Unlike simple variables like ints and doubles, objects will initialize themselves. So the string response here will automatically initialize itself to an empty string. If you don't want it to automatically initialize itself to an empty string, you can initialize it by providing a initial value by saying string fname equals Harry, lname equals Morgan, so forth and so on. You can concatenate two strings, that is, put them together end to end with the plus operator, fname plus lname, but it will not add a space for you. So if you want it to really look right, you should say fname plus quote space quote plus lname. Note that double quotes are used in C++ for strings. Single quotes are used in C++ for individual characters, the CHAR type. Note that literal strings cannot be concatenated. You have to have at least one string variable in a list of things to concatenate. Okay. You can read a string from the console, but when a string is read with the greater than operator, only the first word is placed into the string variable, because as you remember, the greater than operator looks for white space and then stops reading, because it's designed to read more than one value on a line. You can use the getLine function if you want to read an entire line of text. Alternatively, if you want to read a first name and a last name, you can do the same thing we did with reading two numbers on a line and say cn greater fname greater lname. Strings are objects, so they have member functions. These member functions are called with the dot notation. You give the name of your variable, dot, and then the function. So if we have name holding Harry, we can call name.length, and it will look up the length of the string. If we want to extract a portion of a string, we can use the substring member function, where start is the first character we want to look up, and length is how many characters we want to count starting at start. So greeting.substring 0, 5 starts at 0, which is the H, and counts 5 letters, HELLO. Note that C++, like most computer languages, gives the starting position of a string or an array or a vector or any other list of things as 0. This has to do with how those things are represented in memory, but it also is just a convention at this point in, again, most computer languages. MATLAB and R are the two I know that start at 1 instead. Greeting.substring hello world, we want to pull out the world. We start at 7, H is 0, E is 1, L is 2, L is 3, O is 4, comma is 5, space is 6, so W in world is 7. Okay. If you do not specify a length to the substring function, it will just get the entire rest of the string. So greeting.substringparens 7 will start at W and count all the way to the end. So world with an exclamation point. Here are some string operations. I'm not going to try to enumerate all of them for you, but you can pause this slide and try to read through them all on your own. And then here's a complete program example for a string function. Enter your first name, it gets first. Enter your significant other's first name, gets second. And then it builds a string initials from first.substring 01 plus the ampersand character plus second.substring 01. And you can see out the initials. My name is James, my wife's name is Elizabeth, so it would print J and E. Isn't that cute? Okay. All right. Now, I hope that wasn't too much of a whirlwind tour of IO and strings for you to have caught the most important parts. So we're going to take a programming break, and you're going to try to write a program that prints a table of state sales tax rates for 5 states. Pick any 5 that you like. For each state, you should have a string variable with the state name, not the abbreviation, and a double variable with the tax rate. Okay. And you're going to use set precision. You're going to use fixed and set precision to get the right number of decimal places after the dot. And you're going to use set width to line up the tax column so that all of the tax rates line up in a nice little column there at the end. Now the set width for each column is going to be different because you're starting after you print the name of the state. So what I would do is have my column be, say, 30 spaces wide, and so I would say set width 30 minus state dot length, and then that will subtract the length of the state from the column width, and everything should line up nicely. All right, try that out. Let me know how it goes, and until next time, good luck and happy programming.